The following libraries and modules are being imported for machine learning tasks using the Python programming language. 1. Matplotlib. Pyplot. This library is used for data visualization by creating plots and graphs. 2. Pandas. It is used for data manipulation and analysis, providing data structures to handle structured data. 3. NumPy. A fundamental package for scientific computing that supports arrays and matrices. 4. Math. This library provides various mathematical functions. 5. DataTime. A module for working with dates and times. 6. Linear regression from Sklearn. Linear model used for fitting linear models to the data. 7. Standard scaler from Sklearn. Processing used to standardize features by removing the mean and scaling to unit variance. 8. Mean-squared from Sklearn. Metrics utilized to assess model performance by calculating the mean-squared error. 9. Train to split from Sklearn. Model selection used to split the dataset into training and testing sets. 10. Polynomial features from Sklearn. Processing used for generating polynomial features. These libraries and modules are essential for tasks such as building machine learning models, data processing, splitting data for training, and evaluating model performance. Together, they create a robust environment for data analysis and model development in Python. The following code snippet establishes initial variables for a financial analysis. It defines a file name, couple, for a dataset and lists the pertinent columns within that dataset as add close, volume, compound fit, and compound night times. Additionally, it sets the time step for analysis to 4, selects a polynomial degree of 1 for relationship modeling, and initializes the starting financial amount at $10. 0. This code is crucial for configuring the requisite parameters and initial states for financial analysis, including dataset designation, column specification, time step definition, polynomial degree selection for modeling, and the initialization of initial funds for financial computations. These parameters play a vital role in enabling a variety of financial modeling and analysis techniques, such as time series analysis, sentiment analysis, and investment strategies. The code contains a function named buy-sell-stock, which facilitates decision-making for buying or selling stocks based on specific conditions. The function utilizes global variables such as money, stocks, and current date to monitor available funds, stock information, and the date of execution. It formats and processes the date accurately. Moreover, the function references the prediction data frame to obtain insights on the predicted stock fluctuations and the current stock price. By comparing the next day prediction with the current price, it determines whether to buy or sell stocks. In the case of a decision to buy stocks, the function calculates the number of shares to purchase using predefined formulas, updates the stock's data frame with the transaction details, deducts the relevant amount from available funds, and logs the transaction. When selling stocks, the function scans the stock's data frame to identify stocks purchased at higher prices than the current market value. For each qualifying stock, it increases the available funds by the appropriate amount, computes the profit made, logs the transaction, and removes the sold stock record from the stock's data frame. This code streamlines the process of stock trading decisions by automating the decision-making process based on specific parameters. It enhances stock transaction management efficiency and reduces the need for manual interventions. This code snippet reads stock data from a CSV file, processes it, and then generates a new dataset primed for further analysis. The process is as follows. 1. Read stock data from a CSV file stored in the files directory. 2. Converts the date column to a datatime format with the provided format. 3. Creates a deep copy of the original data and column names. 4. Shifts the add close column by the specified step value to create multiple columns for each time step. 5. Removes rows with missing values non-resulting from the shifting operation. 6. Outputs the processed data's head for subsequent analysis. This code is crucial to prepare stock data for time series analysis, enabling the analysis of historical stock prices across different time steps to identify trends, make predictions, and derive insights. Shifting the add close column aligns the data appropriately for time series analysis, while removing non-values ensures a clean dataset for analysis. The resulting processed dataset presents a structured format for in-depth analysis. The script conducts the following operations. 1. Divides the dataset data into training and testing sets using the train to split function from scikit-learn. with 80 designated for training and 20 for testing. 2. Instantiates a standard seller object, seller X, to standardize the features by centering and scaling them to have a mean of 0 and unit variance. 3. Utilizes the seller to standardize the training features HusTrain and testing features CosTest through the fit transform and transform methods, respectively. 4. Chooses the target variable predicted at close for both the training and testing sets, assigning them to utrain and utest. 5. Applies polynomial feature transformation to the training and testing sets using polynomial features from scikit-learn, employing this specified degree polynomial degree. This action generates polynomial features based on the original features to capture potential nonlinear relationships between features and the target variable. This code is employed for data preprocessing tasks including data separation, standardization, and feature engineering before training a machine learning model. Standardization ensures that all features share a similar scale, which can enhance the model's performance. The introduction of polynomial features can assist in identifying intricate patterns within the data, bolstering the model's capacity to fit the training data. This script utilizes the linear regression model from the scikit-learn library to predict stock market prices. Here is a summary of its functionality. 1. Initializes a linear regression model with parallel processing enabled in JobsQuant for faster computation. 2. Trains the model using the training data HusTrain and utrain, where HusTrain contains the input features and utrain represents the target variable for prediction. The code flattens utrain using nip, train, ravel. 3. Uses the train model to predict values for the test data HusTest. 4. Creates a data frame named prediction that contains columns for date from the test data, actual value from the predicted at close column in the test data, and prediction predicted values by the model. 5. Computes the predicted change by calculating the difference between consecutive actual value entries using the diff-period-stone method, then converting it to an absolute value using ABS. 6. Displays the initial rows of the prediction data frame. This code snippet is crucial for forecasting stock prices through machine learning techniques, particularly linear regression. By training the model on historical stock data, it can identify patterns and correlations in the data and make forecasts on new data. The script processes the data, trains the model, generates predictions, and allows for comparison between actual and predicted values to evaluate the model's performance. This code snippet is a fundamental part of an algorithm designed for automating stock trading decisions using a prediction model. The algorithm performs the following tasks. It initializes variables such as the current date, current price, next day prediction, next day actual value, initial money, and sets up a loop to iterate through prediction data. At each iteration, it invokes the buy-sell stock function, assumed to determine buy or sell actions based on the prediction model. It computes profits or losses by comparing the stock's current price with the purchase price and updates the money variable accordingly. Details of the stock sold on a given day, along with the profit obtained or printed out. The algorithm then removes the sold stocks from its list and continues the loop until it reaches the end of the prediction data. In the end, it displays the total money at the conclusion of the trading period as well as the total profit or loss incurred. This code serves the essential purpose of automating trade decisions according to a predictive model and monitoring the evolution of the trading strategy over time. It can be beneficial for optimizing trading approaches, recognizing trends, and basing decisions on data rather than emotional impulses.